Hey guys, welcome back to Maths Cube. Today we are attempting the 8th question on the International Advanced Level Pure Mathematics P2. So without further ado, let's get started. The 8th question is all about a sequence A1, A2, A3 is defined by an plus 1 is equal to 2 into the bracket an plus 3 whole squared minus 7, where A1 is given as p minus 3, where p is a constant. The A bar asks us to find the expression for A2 in terms of p, giving your answer in the simplest form. So the first things first, what we'll do is we'll look at the marks here that have been allotted, and that's 1 mark. This question is of 1 mark, so we won't be spending so much time here. So what you can do is we know that our a1, here you go, a1 is equal to p minus 3, and they ask us to find a2. So guys, to find a2, the expression of a2, we know that our an plus 1 is the formula being given, and we know that our a1 is being given. So what we can do is we can plug this a1 here into this a, where is an plus 1, so our n value is 1 already, that's a1, and a1 plus 1 will become a2. So that's what we are looking for. So in the place of a, I'll plug in p minus 3 and I'll just write it down. There you go, 2 into p minus 3 plus 3 whole squared minus 7. And if you guys can see that I have p minus 3 and a plus 3, so minus 3 plus 3 cancels out. There you go, they cancel out, and we are left with 2 into p whole squared minus 7, and simplifying it, 2p square minus 7, and that's our final value of a. So this is similarly you will put in to find a3. So as we got a2, we'll plug in here, as you can see. So we'll plug a2 here again in this expression to find a3. So that's not our goal or aim here. Now we are done with the a part. Now moving on to the b part. Given that the sigma limit from 3 to 1 an is equal to p plus 15, find the possible values of a2. So guys, to solve this question, given that the sigma 3 to 1, that's a limit, and we have to find the a3 value, or the third value of a, by plugging in a square into the original expression that was given below. There you go. There you go, I've plugged in 8 this second value of a into the original expression, and we have got 2 into 2p square minus 7 plus 3 whole squared minus 7. Our next step will be to simplify it by getting minus 7 plus 3, or just adding 3 into minus 7, which will give us minus 4. And what I'll do is I'll just whole square it, or the both terms. Here we have got 2p square minus 4 whole square again, and 2p square minus 4. So using FOIL method, there you go, that's the result, 4p to the power 4 minus 16p square plus 16. And we'll bring it down where we have to expand it. After plugging it back into the original form, what we'll do is we'll multiply everything by 2 and then subtract it by minus 7. So simplifying it, now after multiplying 2 with the original one, 8p to the power 4 minus 32p square plus 32 minus 7, simplifying the common terms. So our final value for a3 is 8p to the power 4 minus 32p square plus 25. And now what we'll do is, as you can see that I have a sigma sum here from 3, that's n1, from n1 to 3, and we have to add all the a1, 2 and 3 all together and set it equal to p plus 15. So this is the final equation, p minus 3 plus 2p square minus 7 plus 8p to the power 4 minus 32p square plus 25, and that's equal to p plus 15. And they asks us to find the possible values of a2. The very next thing what we'll do is we'll just simplify or cancel the like terms, which is p here, that's the positive p here, and if we take it to the other side, it will become negative, so we'll cancel p from the other side. And then look forward for the like terms like minus 3, that's a single term, and minus 7 becomes minus 10, and 25 and 15 are on the other side. If 15 comes to this side, that becomes minus 15. So positive 25 minus 15 becomes 10, and we already have minus 3 minus 7 as minus 10, so minus 10 plus 10 becomes 0, and we are left with 8p, and we have a positive 2p square at the other side, and minus 32p square. And what we can do is a positive 2p square minus 32 becomes a positive, or sorry, negative 30p square. And we don't have a like term for 8p to the power 4, so it will be written as So our final product comes as 8p to the power 4 minus 30p square is equal to 0. So to find the p value, what I'll do is I'll take or add 30 to the both sides, so that'll become, so we have 8p to the power 4 is equal to 30p square. As you can see that we have p to the power 4 and p square, so this p square cancels out and we are left with p square on the left hand side, so cancelling out that. The next step to find p square will be to divide 8 from both sides, so that will become, so our final p square is equal to 15 upon 4, that's the value. And to find the p value, what we'll do is we'll square both sides, so that will become, so our final p value is root of 15 upon 2 and p is equal to 0. That's the external value, that this is the main value basically. So now that we have got p, they're asking us to find the possible values of a2. So our a2 originally was, if you can see here, let me mark it, 2p square minus 7. If you have p square as 15 upon 4, you can directly plug in, but what I'll do is I'll just plug in 15 upon 2, that's the root of it, so that'll make the same thing. So when I plug in my p square as 15 upon 4, so 2 into 15 upon 4 becomes 7.5, and 7.5 minus 7 is basically a half, so our a2 value as one value is a half. And when I plug in 0 in p square, so 2 into 0 is 0 and we have minus 7 as the last value left. So our possible values of a2 will be minus 7 when we plug in 0 as p, and a half when we plug 15 upon 4 as p square. So these are my final values. Thanks for watching guys, stay tuned for more videos from this series.